So our next speaker is Alan Cadden of Schnabel Engineering. He'll be actually talking about a long-standing project in the geotechnical community that's been sponsored by ASCE, I think the Federal Highway Administration, and a number of other organizations. So,
thank you, Deborah. And thank you, Erica and Al, for setting me up so well before the break. I do really appreciate that. And I just realized when you said it's a long-standing project, this might be older than my kids, and they're graduating from college now. So let's talk a little bit about, hopefully, a solution to one of the challenges that we're hearing about this morning, is how do we exchange that data? How do we turn what is now in a PDF, in a paper format, into something that's interoperable, interchangeable, that we can use from the point the data is collected through the interpretation and analysis and into the design and then future maintenance and operation of facilities. Right now what we have, and we saw some of that from Al's presentation, we have numerous warehouses full of documents. We are great at storage. I like to think we're pack rats. We're not quite as bad anymore. We're starting to at least PDF and store stuff online and make it available in geographic information systems. But PDFs are not data. They're exactly that. They're information. And until we can get to the point where we can actually exchange the data and be able to do some raw analysis on the data itself, we really haven't gotten to a point where this stuff, we're maximizing the value of the information long term. It was interesting, I was talking with this and trying to convince agencies that this is important to use, and I had some DOTs, one of them in particular, said, well, why do I need to share my data, and why do I need data from somebody else? We are the 800-pound gorilla in this state. We have all the information we need. And then you start looking at projects like this. You get into complicated transportation infrastructure projects or urban environments like here in New York City, and you realize that there are no single entities that deal with the underground in your environment. So the information, the data that's out there is going to come from a lot of sources, and we need to figure out how to get them talking so that we don't have 4 or 5 different versions of formats coming from each agency. Further, that information is going to come in a lot of different formats. We saw the test borings coming in. They may be typed. They may be old handwritten logs, cross-sections sketched up over the years, in situ testing, instrumentation, laboratory testing, geophysical studies, just a wealth of information, and we seem to come up with a new tool just about every other year to collect more data in a different format. How do we get that information compiled, aggregated, and then use it in the interpretation and analysis process is really where the challenge comes in. We took a look at just the typical process for a consultant in one of these DOT studies, and irregardless of what's in all the little boxes, every one of those red boxes is where we entered data or re-entered data. And each time you touch that data, there's a potential for an error. So if we can eliminate that, and as Roger Chandler of Kinetics likes to say, there's a golden rule of data. Enter it once, and if at all possible, get somebody else to do it for you. So we want to get this down to a 1 red box, if at all possible. And that's really what DIGGS is intended for. That's what got me interested in DIGGS is we, myself as a consultant, we collect data from a lot of different sources, including our own lab and our own field people. But how do I get that data into the system that can make it useful? And I got really tired of converting Excel spreadsheets and comma delimited files and moving columns around every time I wanted to do something different with the data. So DIGGS is basically the protocol. It's not a database. We don't store any data in it. It's really just the language that we're transferring data from, ideally, the field person into the office, into the graphics program, into the boring log program, into my numerical modeling. Whatever the step is, I don't want to ever have to touch that data again. And that's why we're developing DIGGS. The comment at the top is, the best tools for managing and analyzing data are yet to be developed. We have some really cool stuff out there, but I promise you, if you empower the software developers to create really cool applications and not worry about how they store data and structure the data, we're going to come up with some even better tools in the near future. So that's what DIGGS is for. Just a little background on it. It is HTML format effectively. So if you've ever looked at a web page, created a web page, you kind of know what this system looks like. It's built with objects, and it's objects just really a collection of properties that are describing a single unit. Within that, we have loads of metadata. There's a data piece, but along with it goes a lot of metadata about how that was collected, what the calibration might be, what the steps were in getting to the final data point. We're trying to capture as much as we can and store the structure of that in a common format, a data dictionary, and have rules associated with it so we know we're all entering the data in the same way and storing it in the same way. The objects can be linked. We can have objects that are part of another object, basically a parent-child relationship as the system is being built out. And objects can be part of other objects within the system, so they're all tied together with a common reference or a project ID. So the majority of the properties are built in there. We have, I don't know, probably hundreds of objects in there. I didn't realize how many times moisture contents get used in geotechnical engineering, but it seems like every object has multiple moisture contents associated with the test. So we're able to capture all those different objects, all those pieces. We're going through now, and many of the ASTM, typical ASTM specs or processes are built into the system. Those are all being vetted and making sure that we're robust. But we have quite a substantial system established at this point. If you need to add additional objects to it, there's a way of doing that with the name value pairs, so you're not tied just to the data dictionary we have. If you have particular needs in your agency or your organization to capture additional data, that can readily be done within the system, and it doesn't break what's already there. It is GML compliant, and it also handles points. So if you have a geoenvironmental sample, contaminant sample, that could be a single point. Boring logs of some sort, drilled shafts, foundation elements can be recorded as linear features. And we can also include geometric shapes. So a test pit wall can be documented in here. A rock slope can be documented in the system. So this is kind of what it looks like. The nice thing about it is you can, instead of just seeing a table with a bunch of commas and numbers, you can actually look at this. And if you're really a glutton for punishment, read the file and understand what's going on inside the data file. Right now, this is a system that's managed by the ASCE GeoInstitute DIGGS committee. It's an open source development, so we're not trying to keep anything proprietary. In fact, we're looking for more help to continue to build this out because I think the potential for expanding it into many more tests and many more infrastructure data capturing fields is there. We're at version 2.5. Version 1 was a nice idea. It didn't work at all. Version 2 functions and works well, and now that we've gotten to 5, we actually are in a situation where we're able to develop, read, and write DIGGS files that are pretty robust. We can actually take all of the AGS files now and convert them to DIGGS essentially automatically. So that GINT files can be converted, whole base files can be converted. There's a GitHub environment out there that we're using to continue the development process. We're going through some code list vetting at this point. All the schema is posted there. All the Q&As are out there at this time. There are example files. We do now, it's the chicken or the egg kind of thing. Will the agency start using it? Will the vendors start including it in their software tools? We've finally gotten over that hurdle. We do have some vendors now that are building it into software that are using it and starting to create in-situ testing tools that are able to output DIGGS files. And we have agencies, primarily DOTs, that are starting to implement it. Ohio DOT is requiring this for delivery of their data files. Right now, they're doing the conversion on their own. Within a few months, they're going to be requiring their consultants to provide them in DIGGS format, and several other DOTs are in that same process. One of the biggest milestones that we are finally just about at is that policy kind of question. AASHTO is about to vote on a provisional procedure that's going to require DIGGS files for the delivery of the data from AASHTO tests. So once that gets approved, that'll be a big impetus for state DOTs to say, okay, now we have to start requiring it because we need the DIGGS file because it's an AASHTO requirement. So if we can keep going with policy, getting policies to require it, that's really what's going to drive these kind of common languages and exchanging of data. Thanks.
So, Alan, not to put you on the spot, but I think the burning question is, how does something like this compare to the money initiative from OGC?
I hate to say this, but I'm not completely familiar with all of MUDDY. I don't know how extensive it handles the actual soil and rock mechanics side of things. I think in the long run, OGC and DIGGS need to start working together on this. It's been something that we've talked quite a bit about, but just haven't gotten to that point because we're more focused on getting the system robust.
Okay, thank you very much.